Hello, everyone. Good morning, good evening, wherever you're from. And thank you so much for joining in today's session. My name is Dr. Trishla Punjabi, and I recently scored a 715 on the GMAT. But the interesting thing is that I actually did not start with a 715. My very first score was a 395 with a DI percentile of 10 percentile. But I worked my way up to 97 percentile. And I did that with a very systematic way of looking at DI. And that is what I'm going to teach you today. And the purpose of me saying this is that I don't want you to be concerned wherever you are at right now. If you're at a low point, I don't want you to think that you can't do it. I'm here to show you that you absolutely can. So today we are going to look at TPA questions, and we're going to look at how we are going to solve it and what kind of thinking that we need to have in order to solve it. So let me get started. Just give me a second. I would love to know where you all are coming from. If you can just drop it in the comments where you're joining in from, that would be great. Just letting you know though, there's going to be a little lag, but would love to hear from you guys. Okay, so I hope my screen is visible to everyone. So this is the first mock that I took. I remember I was very depressed after this, where I scored a 10 percentile in data insights, and luckily it jumped up to a 97 percentile. And I think we're just going to dive right into our first question. Hello, Ankit. Lovely seeing you here. Hello, Shubham. Great. We're getting a lot of people from everywhere. That's really lovely. Great. Now we're going to solve this first question. The way that we're going to do it is that I'm going to share a link in the chat. It's a form. I want you to open it, and then I want you to go to the first question. Let me know when you guys are here. Okay. All right, so I want you guys to look at this question. I want you guys to solve this question, and I'll be able to look at your responses once I do. You can just start solving the question. Okay, one thing I want to tell you guys, I want you to be very, very active in this session. If you treat this like a Netflix video that you're watching in the background while having dinner or lunch, that's not going to work. I want you to be very, very active. I want you to solve the questions. I want you to answer. And I promise you, if you do that, if you give your 100%, you will definitely take something of value out of this. So, yes, please solve the question and let me know in the comment box once you have. Okay, I'm getting the answers. A couple of more folks. Going to give you guys 40 more seconds. A very awkward number, 40, but 40 more seconds. Okay. All right. So 5, 4, 3, 2, 1. Awesome. Great. I can see people's answers. I can see approximately 7 people have replied, and the accuracy rate is less than 50%. So let us look at how to solve this. Let us look at a very systematic way to solve this and how to get that systems thinking in place. Perfect. So, this says a corporation recently expanded both its sales department and its technical department. Okay. Immediately before expansion, the number of employees in the sales department was exactly 60% of the number of employees in the technical department. So, what does this tell you? Number of employees in the sales department is 60% of the number of employees in the technical department. How will you demonstrate this information? What are the different ways of looking at this information? What are the inferences that you can get out of it? One is definitely algebra. Okay, we can see that, let us say sales is 0.6% of technical. Okay, we can form an equation. Drop any other ways if you have in the chat. What are we going to do with this? The number of employees in sales, 60% of number of employees in the technical department. Another way we can do it is, let us say, if we consider sales is 60x, technical is 100x. Okay. What else? What if we look at it as a ratio? Right. What if, let us say that the ratio is 60 is to 100. So if we simplify that, that is what? 3 is to 5. So what does this ratio tell us? Can there be 7 employees in the sales department? Is it possible for there to be 7 employees in the sales department? Absolutely not, right? Because a person is obviously going to be a whole number. You can't have half a person. So the first number has to be a multiple of 3x, and the second number, the number of people in the technical department, has to be a multiple of 5. So if you look at it, what are the different possible variations? What are the different possible combinations of the existence of this particular system? There could be, let's say, 3 employees, 5 employees. There could be 6 employees, 10 employees. There could be 9 employees, 15 employees. So you see, if we had gone in the algebraic method, and there's absolutely nothing wrong with the algebraic method, there are many ways to solve a question. But if we had solved using the algebraic method, at that time, we would be left with one equation, s is equal to 0.60. We don't know the value of s, we don't know the value of t. That would make things so much difficult, right? But here, what are we doing? As we are looking at the question, as we are immersing ourselves into the question, we are looking at these numbers, we are looking at these relationships. And let's have a look at what they're actually testing here. In data insights, they are not testing how good we are at math, they're not testing how amazing we are at algebra. Data insights, the word means that when we look at that data, when we look at complex data, how are we finding ways in our own head to simplify that data? And that's what we are being tested on. Because as a future business leader, that is what we're going to have to do, right? We're going to have to look at heaps and heaps of data and get usable information out of it. So they're making us practice that right now. So I want you to start this practice, in this session and also in the other sessions going forward. When you're doing questions going forward, whenever you're looking at this, just look at it. Okay, what can I infer? What can I infer? What is it that I can get out of this? Okay, perfect. Let's move back onto the question. So the ratio was 3 is to 5. Immediately after the expansion, the sales department had exactly 12 employees and the technical department had exactly 15 employees. Right. So what does this say? 3 becomes 12 and 5 becomes 15. Okay, so this is what is there after. Can the number before number, can it be 9 is to 15? Think about it. Is it possible for the number of employees before to be 9 and 15? Absolutely not, right? It is absolutely not possible, because it is said that after there was an expansion, the sales department increased, so the number has to be less. So right now we have only two combinations, 3 5 and 6 10. So instead of testing out multiple values, we can only test out these numbers. So let us see this. So select for sales and technical percentage the increase in the number of employees that the sales department and technical department respectively could have experienced during expansion, such that the percentage increases are jointly consistent with the information provided. So now instead of testing every single value, instead of solving very, very difficult algebra, we have something very simple for us. We just have to test out two things, 3 5 and 6 10. Let us look at 3 and 5. Let us say the value was 3 earlier and then it shifted to 12. How much percentage increase that is? That is a 300% increase. That's not there in our option. Our max option is 100. So 3 and 5 is out. Let's look at 6 and 10. 6 became 12. How much is that? That is 100%. 10 became 15. How much is that? That is 50%. And that's our answer. So actually, I took too long explaining it, but when you're actually doing it, right, you can do it so much easily and so fast. So I want you to, inculcate this practice going on. That whenever you're solving a question, especially TPA question, I want you to think about, okay, even if you get it right, I want you to think about 2 to 3 different ways by which you can solve it. One of them has to be short. It's okay if you spend like 20 minutes on a TPA question, but this is what I want you to figure out, because I want you to understand how you can get an inference, how you can get an insight out of the data. And once you are doing what they want you to do, once you're actually doing what they're testing you on, your scores are going to skyrocket for sure. So let us move on to the next question. Okay. You can click on next in the form that is given to you, and you will be able to see the question. You have around 2.5, 3 minutes to solve this. Can you see the question? Can you click next? In the given form, in the same link that's shared with you, just click on next question. You'll be able to see it. Okay. I see a lot of people are on question 1. Please come to question 2. I see a lot of people have started solving it. I'm going to give you 40 seconds more. You can start dropping your answers in the comments as well. Okay, last 5 seconds. Five, four, three, two, one. Okay, let's begin solving this. But actually, before we solve this, I want you to solve this question. Let us say your teacher is giving you the class average test score for three tests. In test one, the average was 75. In test two, it was 80. In test three, it was 85. And your teacher also mentions that, okay, by the way, one student scored 45 on test one and another scored 98 on test three. And now you need to make a graph showing how the class average changed over the three tests. What would you plot? Would you plot A, all the five numbers, all three averages, and like the 45 and the 98, all of that? Would you plot B, only the class averages, or would you plot C, only the individual scores? Drop it in the comments. What is it that, what would you plot? So I'm assuming that you would plot B, right? I think isn't that like extremely obvious that you would plot B? This is something wherein if you need to make a graph showing how the class averages have changed. So for the average, you will only plot the average. Is the 45 here and the 98 relevant? It's not, right? We are supposed to plot the average. We have the average. Who cares what one student scored, what the other student scored? We only care about the average. Now, let us go at, okay, sorry. Now, let us go back to this question. And let us read this question. And this question has an accuracy rate of less than 50%. And we'll also get down to why that is. So what, and this is like a very dense data set. So let us read through it very carefully. Let's see what's happening. Throughout a certain decade in European city, decade means that there's a 10 years thing that we're talking about. The mean monthly rents for the studio apartments varied yearly from a low of 804 to a high of 1173. So, what is this telling us? So, this is telling us that if we are talking about studio apartments, there was a range. What is this telling? From a low to a high. What is this showing us? This is showing us the range of studio apartments, right? From 804 to 1173. This is the entire range. Those for one bedroom apartments also varied yearly from a low of 1060 to a high of 1497. What is this showing us? Also the range. 1 BHK, it is 1060 to 1497. All right, this is also our range. So, but some individual studio apartments rented for as little as 420 in some years, and some 1 BHKs rented for up to 2262. Now, is 420 and 2262, is it the mean? Think about it. When we are talking about $420, when we're talking about 2262, is it the mean? Let's go back here. Oh, where's that question? Sorry. Let's go back here. 45 and 98. Was that the mean? No, they were just two random values, right? They were just a couple of outliers. They were not the mean. Similarly, here 420 and 2262, that is just some data point that is there. It is not the mean. We already have the range for the mean. This 420 and 2262, it is not the mean. Just keep that in mind. You'll need it later. To visually assess how the ratio of mean monthly rents for studio apartments to those for 1 BHKs varied yearly over the decade, Maria requires a graph with the following characteristics. The graph will have two axes of equal length. So, drop this in the comments. When you hear two axes of equal length, what does that mean? What does that signify mathematically? Two axes of equal length. Think about it. If both of them have the equal length, that means that the range will be the same. That is the only way that they're going to have an equal length. Right. So, what is this statement telling us? That they have the same range. So, this is actually the process of what we are supposed to do. We are supposed to look at each and every data point that is given to us. We are supposed to think about what it actually means before we go in to solve the question, right? We are supposed to extract the insight out of the data that is given to us. We're supposed to reorganize that data. Great. Space between 2 points. Um, in this, basically, technically, we can say that if it is a range, it is like a space between like the first value and the last value. So two axes of equal length may mean that. So yeah. All right. So what are these values looking at? What are they actually charting here? With mean rents for one bedroom apartments shown on the horizontal axis and mean rents for studio apartments shown on the vertical axis. So if we are visualizing what is happening here, we are looking at the horizontal axis and the vertical axis. What does the horizontal axis have? Mean rent for 1 BHK. And what does the vertical axis have? The mean rent for studio apartment. And again, are they talking about rents? They're talking about the mean rent. So the only values that will be charted will be those of the mean. Now, question to all of you. Will 420 and 2262 be charted or not? Think about it. Will these two values be charted or not? What are we charting here? What is this entire graph for? Mean rents. Are 420 and 2262 mean rents? No, correct. They are absolutely not mean rents. So we will not be charting 420 and 2262. One of the beauty and magic of data insights is knowing what data to use and also, very importantly, what data not to use. And in this case, it's a perfect example of what data not to use. Perfect. So let's move ahead. For each year, the mean rents will be plotted as a point. They're making it even more clear that we are only talking about the mean rents. So from the following options, select from horizontal axis, arrange for the points on the horizontal axis, select for vertical axis, arrange for the points on the vertical axis, that together would satisfy Maria's requirements for the graph, make only two selections. So basically, we need to look at options that will include 804, 1173 for studio. So, and studio, where are we charting? We are charting it on the vertical axis. Sometimes, I've seen, and it's even happened with me, that you get the answer correct, everything is correct, everything is perfect, but you just mistake the columns. That I chart for studio on the vertical axis and 1 BHK in the horizontal axis. That does happen. So we have to be very, very sure that that is something that should not happen in TPA. Okay, so 8041173. 0 to 1500. Can that take 804? Yeah. Can that take 1173? Yep. 400 to 1100. Can that take 804? Yeah. Can that take 1173? Mm-hmm. It cannot. 800 to 1200, can it take? Yeah, it can take both. This can also be an option. 1000 to 2300, can that take 804? Nope. 1100 to 1500, can that take 804? No. So what are we seeing right now? We know the limits of the range. So if we are charting a particular graph, both the limits have to be there on the graph, right? Only then it is going to be an accurate graph. So we are seeing which of these could even be contenders for the studio one, right? But what is the studio one again? Let's see, vertical axis. Okay, so we are checking for the vertical one. Only these two can be potential options there. Now, let us check for the horizontal axis, the 1 BHK. The range is 1060 to 1497. 1060 to 1497, can it be a part of the first one? Yeah. 0 to 1500, definitely it can be. 400 to 1100, can it be? Nope. 1497 is more than 1100. 800 to 1200, can it be? Nope. 1497 is more. 1000 to 2300, yep, it can be that. And 1100 to 1500, can it be that? Nope, it cannot be that. Yes. But if you look at it here, so now you have two contenders for the vertical axis and you have two contenders for the horizontal axis. Now look at the constraint. What is the question saying? Same range. So either the range has to be the same. So in the first option, the range is the same, 0 to 1500. So that could be the correct option. If you look at all other options, right? If you look at just the green part, this range is 400, right? And if we look at this range is 1300. So this cannot be the case because it is not fulfilling the constraints of the argument. So the answer is that for both, it is 0 to 1500. Is that clear? Okay, great. I am moving on. If you have any takeaways, please feel free to drop them in the comments. And have a look at this question. Can you see this question? Can you access it in the form that I've sent you? Just start filling it up from the form. I'll have to stop my screen share for just 1 minute. Please look at the question from the form. Have you guys started solving the question? Put the answer in the chat box if you have. Since it's a difficult question, I'm just going to give you 40 seconds more. Okay, so we can start solving now. A manufacturing company plans to begin automating production and reducing its workforce by installing industrial robots at the start of each year over 5 years. Each robot will result in an annual labor cost savings of $150,000 beginning with the year of its installation and will have an upfront cost of $400,000. Now, guys, I have been facing a bit of a tech issue, so it will be a little bit uncomfortable. So please bear with me. Just give me a minute. Mm, yeah. So what it says that for each robot, what is there is that there is going to be a $400,000 upfront cost. Sorry, upfront cost, and there's going to be a $150,000 of savings. Okay. All right. For robot installation in year one of the program, the company will budget $600,000 plus the total amount of labor cost that is going to be saved by robotic production in that year. All right. So, what is this telling us? That the company is going to budget. What is the budget? That is going to be $600,000. Okay, let me just make that six a little bit better. Plus the savings from the robots. Okay. The robot installation budget for each subsequent year will consist of the total amount of labor costs that will be saved plus any money left over from the previous year's robot budget. Okay. So let us say that for any subsequent year, if we're talking about year one, year two, year three, so year two and going forward, the entire budget, so this is the budget for the first year. For the entire budget, it is going to be leftover plus savings. Okay, so I think this is like something which is very dense. There is a lot of information here. There is an upfront cost. There's a savings from the robot, 400, 150. There is the budget, which is 600, and there is savings. So this is something which seems very dense, right? It seems very difficult to do it, especially in the given time period. It seems very difficult to do it. But now what it says is that within budget constraints, the maximum number of robots that can be installed in year one of the program is X, and the maximum value of robots that can be serviced in year three is Y, and select the values for X and Y. So if we look at it, right, and if we try to figure out equations wherein we have 400,000, 150,000, 600,000 savings, it is going to be very, very complicated. You could come to an answer, but you could spend like lots and lots of time. You could spend like, 4 or 5 minutes coming to an answer, and you do not have that much time. And there's a reason that this is one of the hardest questions out there. It is one of the most difficult questions with the least accuracy. So this is difficult, right? But let me show you this question. Imagine you run a lemonade stand. Okay. You are starting with $100 in your wallet, and each lemon is costing you $5. And the moment you buy a lemon, somebody gives you $2 back. So, what is the real cost to you per lemon? Drop it in the chat. What is the cost to you per lemon? $5, $2, or $3? $3, right? If a lemon is costing you 5, but every time you're buying it, somebody is giving you 2 back. So essentially, it is costing $3. So if I want to buy lemons with all of those $100, and if I want to calculate how many lemons I can buy, I can have two methods. I can first look at, okay, you know uh, what are the real cost? Okay, let me explain to you the real cost to you per lemon. Wait, you are starting with $100. Okay, that is the money you have. The lemon is okay. Okay, I went saying $3. All right, great, wonderful, wonderful. Okay. Now, if we, yeah, so the real cost to you per lemon is $3, right? So if you are starting with $100 and then you have to figure out how many, lemons you can buy, there's either two things you can do. Either you can look at, okay, there's $100, each lemon is costing me $5, so 100 by 5, I will do $20. Sorry, 20 lemons. Then how many dollars do I have left? Wait, I was getting $2 back, right? So, oh, wait, I'll have $40 now. And that is going to make it so confusing, right? That is going to make it so damn confusing, because there's going to be so many different ways that you can do it, and there's going to be so many equations, and this is where you can have calculation mistakes. But now that we know that the cost to you per lemon is $3, so we can just say, oh, 100 by 3, $33, sorry, 33 lemons, and we have $1 remaining, or $20 remaining. Right. So this did not take any equations. Figuring out how many lemons to get from $100 did not take any equation at all. We solved it simply using logic. Now let us try to apply that same principle here. What is it saying? Right? Basically, the robot is a lemon. There is $400,000 upfront, and there is a $150,000 saving that you're getting each year. So how much is it actually costing? It's actually costing $250,000. Let us not work with these numbers. Let's forget this. Let us only work with $250,000. So if a robot is costing me $250,000 and the budget is 600 and savings from the first year, that makes my life so much easier. I have much lesser variables to deal with right now. I can actually look at the question and I can solve it. And this is what inferring from the data set is. This is what drawing inferences from the data set looks like. This is actually doing work of data insights. And this is what they want you to do. They don't want you to do really complex calculations. They just want you to apply logic, simplify that data, and then work on it. Now, with that simple data, if we look at it, year one, what do we have in year one? Let us go back to the question. Year one, we are the company's budgeting 600K plus the total amount of labor cost saved by robotic production in that year. Okay. So it is 600K plus whatever is saved by robots. But we already have, we've already included it as 250. So if we have a robot is costing 250K, we have 600K. How many robots can we buy? We can buy 2 robots. 250, 250. That's essentially 500, right? And we are going to have 100K left over. Perfect. So let us look at the options here. The options here, yep, 2 robots. So the answer for X is 2. Now, if we look at what is happening every year on from there and forth. So year 2. Year 2, what is our budget for year 2? Let us go back to the question. What is the budget? For year 2, the robot installation budget for every subsequent year will consist of total amount of labor cost plus any money left over from the previous year's budget. So what is that going to be? Let us say we have 250K. So right now we have 100K left over. And remember, the 2 robots that we got here, they are still going to be functioning, right? So these robots are going to be saving 150K into 2, that is $300,000. So total we have $400,000. This entire one robot is costing $250, so we can just buy one robot. Did you get the logic here? What did we do here? Essentially, one new robot costs 250. What do we have? We have the leftover amount, which is 100K, because for two robots, we had to spend 500K and we had 600K to begin with. So we had that leftover amount, and we had these two robots who were also working the subsequent year, right? Because we just have to pay $400,000 once. We don't have to keep paying it again and again and again. After that, the robots are going to work for us. After that, the robots are just going to give us $150,000 every year. So two robots working 150,000, they gave us 300, so giving us a total amount, a total budget of $400,000, wherein we could purchase one robot. And how much were we left with? We were left with $150,000 at the end of it. So up until now, how many robots we have? Three robots. Now let us look at what is happening in year three. Year three, what is the amount we have left? $150,000. Now, how many free robots do we have that we did not have to pay for that year? Three. How much are they paying? They're paying 150,000. So we have $450,000. So that is 450 plus 150. That is $600,000. So what can we do from $600,000? We can get two more robots. So how many robots do we have left? 2 plus 1 plus 2. Total 5 robots. So the answer is 2 and 5. Now, anyway, I know this is a very, very complicated question. But had we done it using the original way, had we put in 400 and 150 and all of that, that would have become so much more difficult and so much more messy. But here we could completely break the data set. And we could just look at what is the cost of robot. We could just look at what is the amount that is left over. And we could look at the robot savings from past robots. So just based on these three things, we were able to get this. Right. If we would have done it the original way, it would have become a lot more complicated. But is this clear to you guys? Does this make sense? Great. Now, I want you to do this question. You have 2 minutes. In the form, go to the question number 6 and solve this. One more minute, guys. As soon as you start getting done, you can also drop your answers in the comment section. Final 10 seconds, guys, and we'll move on to the explanation. 5, 4, 3, 2, 1. Okay, let's go. A certain theater has 500 seats. Some are on the main floor and sell for $50 each. Some are on the first balcony and sell for $45 each. And the rest are on the second balcony and sell for $35 each. So, what does this data tell us? Right? Let us look at it. The certain theater has 500 seats. So, if we look at it, again, I'm really sorry for the tech issue, guys. Yeah. So if we look at it, so there are three kind of seats. What kind of seats are there? There are, uh, let's have a look again. Main floor, first balcony, and second balcony. Okay. All right. So we have main floor. We can denote it as M, first balcony, and we have second balcony. So we have a total of how many seats? 500 seats. So M plus F plus S is equal to 500. Then what other information do we have up so far? The main floor are selling for 50, M is for 50, first is for 45, and second is for 35. So, okay, main is selling for $50. First floor is selling for $45. Second floor is selling for $35. Okay. What other information do we have here? Uh, when all the seats are sold in a performance, all of them, okay, the gross revenue of that performance is 20,900. Okay. Yes, absolutely correct. Absolutely. 50x plus 45y plus 35z, that is the exact correct expression. So we have 50m, but I'm just taking an mfns, plus 45f plus 35s is equal to 20,500. So we have two equations, equation 1, equation 2. Okay. Then of the three seating areas, the second balcony has the most seats. So what do we know? That S is greater than M and S is greater than F. Okay. So this is all of the information that has been given to us. So what did we do first? We converted this information from something which was given in a verbal format into something which we could form it in equation, something which we could easily understand, something which we could easily internalize. So select for first balcony, 20,900. Oh, sorry, my bad, guys. 20,900. Thank you for correcting me. Yeah, I mean, this is actually reflects a common type of mistake that I used to make, wherein like the question would be right there, everything is correct, I would just copy it down wrong. And I'm glad that I made it right now so that you can see that this is what not to do. Great. So, first balcony, number of seats in the theaters, first balcony, and second balcony, number of seats in the theaters, second balcony. So, we need to find out what is there in the first balcony and what is there in the second balcony. So, let us have a look at our two equations first. And a lot of people, when they look at this, because this question also has a very low accuracy rate. I mean, we did say that we'll choose the hardest questions. So this has a very low accuracy, but if you look at it, right, what is the main thing? What are we supposed to find? We are supposed to find F and S. We have two equations. Are we supposed to find M? Are we concerned about M at all? Is M asked for at all? No, right? So, and since we have these two equations, so our job right now is to remove m. Now, how can we remove m? This is something like very basic. This is, we have m plus f plus s is 500. We could just multiply it by 50. So we have 50m plus 50s f plus 50s is equal to 25,000. Is it 25,000? Because we're multiplying it by 50, right? 5 5 is 25. Great. Now m is gone. So what do we have? We have 5f plus, this is minus, again this will be minus. We can actually take 5 in common also. Okay, and wait, we do this. 5f plus 15s is equal to, what is 25,000 minus 20,900? Let's just do this here. Sorry, guys. So this is one more habit that I have, that even if it is like common things, I will still, follow the main process. I will still do that subtraction just because it is so easy to get these simple things wrong. And I really don't want to do that. If I'm getting it wrong, it should be because I did not understand the logic, not because of a calculation mistake. Okay, so what is f plus 3s? 4100. Oopsies, sorry guys. 8, oopsies, 820. So 40, 1, 5, 2 are 10. Okay. How many of you got to this equation? Were you able to get to this main equation part? Yeah, drop it in the chat if you could get to this equation. Even if you could not, it's okay. So one of the first mistakes that people make is because there is so much data, right? We have m plus f plus s, we have 50m, 45f, 35s. So people get really confused. They cannot make that main equation. But I'm very happy that you could, and that's really, really fantastic. And let us see what we do after that, right? So we have this equation, we worked on the data set, we came to the answer. Now, if we look at what are the two selections that we have to make, right? Two, one in each. So if we were to, if we had to do it, then we would have to, okay, I'm very happy to see that, a lot of you could get to this equation. Really proud of you guys. So if we were trying to substitute everything of f in this equation, like, okay, f is 100, f 150, f 190, f 210, that would take forever. That would take 3, 4, sometimes even 5 minutes. So let us look at what we can infer just from this. Just from this equation, that f plus 3s, that is 820. What is it that we can infer? If you can drop, what is it that we can infer? Whatever you think, you see this equation, you see these option choices. What are the insights that you can get out of this? Think about it, and then I'll give you a clue. Think about multiples. What can you infer? Look at me. Yeah. F plus 3s is 820. That s is a multiple of 3? Not necessarily. Let us say if we had 6 over here, s would be 2. It's not a multiple of 3, but 3s as a whole is definitely a multiple of 3. 1 is to 3. Multiple of 7. Okay, so z is in the second balcony. That means it has to be a multiple of 7 since it is $35 each. Hence 210. Okay, interesting. So I'll tell you what could be potentially inferred. Is 820 a multiple of 3? 8 plus 2, 10. It's not a multiple of 3, right? Exactly. Bang on. F is not a multiple of 3. Great. Good going, Soumya. I hope I'm pronouncing your name right. So F is not a multiple of 3. So now, instead of testing every single option, what do we have to test? Do we have to test 150 for F? No. We know that F is not a multiple of 3. Do we have to test 210? No. So what do we need to test? We need to test only 100, 190, and 250. 300 is also out. So instead of testing all of these values for F, anyway, 300 was out to begin with, but instead of testing all of these values, now we are only left with 3 values to test. Why? Just because we inferred this multiplicity, the principle of what is a multiple of what. Just because we could infer this one simple principle, our job is essentially cut to half. So that is what the purpose of this question is. This question does not, uh, yeah, exactly. It's only either like 190 or 250. This question is not to check, if you are able to do maths really fast, or did you have to do all of this complicated subtraction thing, or were you smart enough to just like do the subtraction as it is? They don't want to test that. That is not the purpose of this. They want to test that can you actually get to this inference? Can you actually use what you already know in this to make the data easier for you? That is the major purpose. So if we look at this, so now that we are only left with just a couple of data points for F, here if we start substituting, we'll be able to find, let's substitute 190. So if we are substituting 190, so we have 190 plus 3s is equal to 820. So S in general is going to come up to, if someone is faster than me, please put it in the chats. 3, 6, 630 by 3, 210. S is equal to 210. That matches one of the answers that is there. So F is 190 and S is 210. So you see how doing something like this can actually really, really help in a question like this. Great. If you have any doubts up until this point, please drop it in the comments. If there's anything new that you learned in this session up until this time, please drop it here. And we will move on to our very last question here. Okay, this is a little bit cut, but I hope that is it visible? I think the main thing you're able to see, so I think that should be fine. Okay, I'm giving you 2 minutes. Please solve this question. Getting cut to the right. Yeah, give me a minute. I'll just tell you. It's at least one word is being cut, for which according to the design you'll be able to see. Fantastic. Great to see that, Aditya. And I think that's what, right? We are able to form equations. We are trained in algebra. We are trained in, knowing how to do all of this. But inference is something that we are not usually used to do. We are coming from that mindset of solving questions, solving it to the very end, figuring out what the exact answer is. But data insights is not about that. Data insights is not about solving the entire question. It's about seeing what could be the possible data, what could be the possible variables. It is about analyzing the constraints, analyzing the structure, and then drawing as many insights, as many inferences that you can out of it. Right. Now, please do this question. I'll shush. And if you have any questions, please tell me. I just did this so you can see the question fully. But machinery and cropland, which one is which? Which one is greatest? Which one is least? 30 seconds more, guys. Okay, final 10 seconds. Okay, great. Now let's see how we did. This question also has overall like a little bit poor accuracy, but I think you guys did do well here. Okay, all right. So let us look at this question. Let us look at what this question is saying. A farmer wants to allocate her expenditures to maximize her profits during the coming year. Let C be her spending on cropland, F on fertilizer, L on labor, M on machinery, and S on seed. She has estimated that if she allocates at least 100 euros to each of these categories, then her profit will be this particular expression. So let us first write down this particular expression. What is the entire expression? It is saying C minus 97, L minus 92. Sorry, my bad. Yeah, C minus 97, L minus 92. We have S minus 95. Sorry. Okay. Yeah. Just give me a minute. There's something going on. Let's just make a new one. Yeah. Okay. So minus 95. Sorry, L minus 92, S minus 95. S minus 95. Then what do we have? M minus 87 and F minus 90. So this is the entire big long expression that we have. And what we want to do is that if we want to, she wants to calculate the benefits of expenditure greater than 100 euros in one of these categories if she were to spend exactly 100 euros in each of the others. So this entire thing itself is giving us a clue. What is this entire thing saying? So are you able to grasp what I'm saying up until now? Are you able to see my screen? Okay. Okay, great. So this entire thing is saying that, let us say, what happens if it, what happens like at 100, right? So if we look at, imagine that we are putting 100 into each of these categories. 100 minus 95, 100 minus 87, 100 minus 90. So what are we coming up with? 100 minus 97 is 3 into 8 into 5 into 100 minus 87 is like 13 into 10. So this is our expression. Were she to spend exactly 100, at any of this, and I'm sure like a lot of you followed this exact same methodology in doing this. Now, what does the question say? It is saying that select the greatest returns for the resource, which according to the desired calculation, each euro of spending beyond $100 is going to make the greatest contribution to profits or the least contribution to losses. Right. So what is this saying? So it's basically a maximum minimum problem. We have to find out that if we were to spend an extra euro, would that what would give the maximum and what would give the minimum? Okay. So if we are having a look at this expression again, a lot of people, and I think initially when I had started out and when I had freshly started to learn how to do this, at that time I had thought that, wait, if I am increasing 3 to 4, because 3 is a small number, the 4 is going to a small number, so that is going to be the least, and we have 13. So if I am increasing from 13 to 14, that is like a big number. Okay, so that might be the most. So this is what like a very linear thinking. This is thinking like, this is the mistake that not just me but most of the people make in this question, where they just look at this that, okay, if the number is small, then the answer is going to be small. If the number is big, then the answer is going to be big. And that is a very common trap. That is a very common fallacy, and that is what kind of GMAT wants you to avoid. So what you can do in this case, if we the best case to do is test it out. What is the question stem saying? It is saying that according to the each euro of spending beyond 100 euros. So it is actually telling us what to do. It is giving us very clear, very explicit instructions of what to do. Each euro beyond one. So we know, like I think right now at this point of know that we know it is either 3 or it is 13, right? So we know that it is either cropland and machinery. Both of them are going to be the one of the answer choices, but we have to figure out which one of that is which. Okay, so let us say that we are first increasing cropland. Okay, so cropland, the 3 becomes 4. The rest of them are as it is, 4 into 8 into 5 into 13 into 10. Okay, so this some expression is going to come up here. And we are going to have a second test where we are going to test 13. Like what happens if we work on 13? What happens if we work on machinery? So there, excuse me, we are going to have, yeah, we're going to have 3 into 8 into 5 into 14 into 10. Okay, so here, if we want to compare these two things, we don't need to go through the entire process and we don't need to multiply all of that. We know that 8 is common, remove it, 5 is common, 10 is common. So what do we have here? 4 and 13 or 3 and 14. Okay, so what is 13 into 4? That is 52. And what is 14 into 3? 42. So what is happening here? When we are increasing from 3 to 4, so what did we do? We worked on the C, we worked on the cropland part of things. So when we are increasing it from 3 to 4, our profits are higher. Whereas when we are working on the machinery, M87, when we are increasing it from 13 to 14, what is coming up? 42. Yeah, yeah. And honestly, like that's me. I mean, that was exactly my own reaction. So sometimes, it's just easier to test it out. It's just easier. That's why I insist on doing like every single calculation, every single subtraction, multiplication, no mistakes at all. Because this is so easy, right? But it is just something that you do tend to fall into. GMAT wants you to fall into those traps. So this is how you can test it out and then you can come up with the answer, the maximum minimum. Great. I hope that this session was helpful for you guys. This is all for now. We're going to have our, I think, next session soon. Thank you so much. If you have any questions, please drop them. Once again, I'm really sorry for the technical error that happened. If there's anything that you learned from this video, anything that you're going to take away from this video, please drop that as well. Like the main, how much extra euros needs to spend for increase from 3 to 4 and 13 to 14. So here what we are doing is, well, let's look back at the question stem. What is the question stem saying? That select the greatest returns for which each euro of spending is going to make the greatest contribution to profits. Right. So what we did here, uh, just give me a minute. Yeah. So what we did here, like this, in this entire expression that we have, oops, in this, yeah, entire expression that we have, we kept everything the same. We knew that, there's going to be that if we move 3 and if we move 13, only then there is going to be some change. So we did not have to move any of the numbers. In a maximum minima problem, you only need to move the two extreme parts of it. So what did we do? So like, okay, we thought that, okay, what if we give an extra euro to 3? An extra euro to 3 would be 4. So the entire expression would be 4 into 8 into 5 into 13 into 10. Or we could give an extra euro to 13. So that would be 3 into 8 into 5 into 14 into 10. Right? So that's what we're doing. So we're calculating what the normal thing is supposed to be. And then we are seeing that, okay, if we increase one, what is going to happen? And then we are going to visualize what actually happens. Exactly, spot on, absolutely spot on. 3 to 4, that is going to be a very large percentage change. And this again falls into something which is, like a quant thing that you should know about percentage changes. But I mean, see, even if, at that point of time, because there's so much data, you're going to be swimming in data. So at that point of time, even if it is like very hard to come up with this entire thing that, okay, how do we, will this be a percentage change? Will this be an increase? Because you're taking minus 97, then you're putting, then you're putting that 100, and then it's so confusing. So it's sometimes it's just easier. At that point of time, 13 into 4 is easier. Great. I hope that this session was helpful. If there's any other takeaways that you have, that you are going to incorporate in the future, please do let me know. I think if there's one thing that I want you to do, that I want you to practice going forward, is that whenever you're looking at this STEM, right, just think about it. The people who design the test, they want to check how good you are at taking the data and getting inferences out of it. They do not want to check how good your calculation is. They don't want to check how fast you see all the answer choices. It takes up, yeah, I know, I do know, understanding the AI questions take so much time. But the way that I think about it, it's like driving. Okay, so I actually am a very bad driver. I'm really, really horrible. But when I started learning how to drive, I was much worse. But I did not start learning how to drive at 80 kilometers per hour or at 100 kilometers per hour. I yeah, I would have, I think, caused so many accidents had I done that. I started to learn at like 10, 15, 20, and I took my time. And because I took my time in actually understanding and actually learning how to drive, right now I can go up to 40 and have much fewer insults coming my way than I used to. So that's the thing. Like, if you front load your time, if you spend 15 minutes, 20 minutes on one question, just understanding it and then solving it, then you will get a hand for it. You will get a skill for it, that, okay, this is how you do it. So at that time, when you see a fresh question on the GMAT, and this is, my own experience, at that time, I do not have to think that, oh shit, like what to do, this method, that method, this method. You will not get confused. You will know, oh, wait, I had seen this question. I had practiced these three methods. This one was amazing. Oh yeah, here two things are related. Ratios. Quickly, let's go. You are actually building up the practice, and that's what I want you to do. And when you are solving the next set of your DI questions, I want you to draw inferences, and I want you to think that, okay, this is one way that I solved it. What are two other ways? They could be longer, they could be shorter, but just think of it. So when you do that, you're going to immerse yourself in the data, and you're going to see what insights come out of it, and you're going to become better and better and better. And that's what I would recommend. So I want you to see. So right now, we all spend so much time together. You guys gave me, like, I think close to 1.5 hours of your time. You must have like so many important things to do, so many questions to practice. Yet you gave me the time, and thank you so much for that. But like, right now, now, you went. Oh yeah, just give me a minute. Yeah, so right now, you went, uh, you figured out, okay, this is the theory. Oh, right, I should use ratios. Okay, maybe I should test, maybe I should infer. So you know all of this in theory. But what I want you to do is now cement it into practice. So I'm going to share like share a list of I want you to go to EGMAT. I want you to go to the TPA section, and I want you to practice the questions there. And I want you to use these things. I want you to use inferences. I want you to look at exactly how to extract information from the data set. I want you to spend 10-15 minutes if it's required, but I want you to know how to follow the process, and I want you to get that. And I think once you do that, now you will see what works out best for you. You will discover yourself that, okay, wait, what if I had done this question by ratios? oh, I could have used something else in this, and it would have been worked out. It would have worked out perfectly. So that's how DI, even with lesser questions, you can do a lot of practice. Great. Awesome. Hmm. Wonderful, wonderful. So, yes, again, thank you so much for joining. And please do go and please do solve. I really don't want that, so much work we have done here together, it should go to waste. We really need to practice, we need to cement, and, we need to kill it. I'm increasing competition for myself, but I really want you guys to score more than me. 99 percentile, all of you. That's what I want. Awesome. Great. Thank you so much, guys. Yes, all the very best. Have a good morning, good evening, good night, wherever you're from.